Okay, so we're still working with this Kioptrix-1 box. Last time we explored the Samba vulnerability and used the trans to open exploit. But as you can see here, right on the login prompt for the Kioptrix-1 box, it tells us there are many ways to get to root on this box. So let's try and find another one. As a reminder, this is the results of our Nmap scan. There was lots of good stuff to take a look at. So the old OpenSSH, and if you recall, I mentioned Apache was something that caught my eye, and that's what we're going to explore today. So I found this write-up. I'm not going to say the name of this exploit out loud, so no need to grab the swear jar. But yeah, it's not a very family-friendly name. Anyway, so how did this person find this? Well, I did a quick, not a Google search, but a DuckDuckGo search myself, and it was the first two results. I noticed that this 764 version was the same one that this person linked to, and they said that they had issues with it, so we're actually going to explore the other link and see if we can do that. If you look at the bottom of my screen there, 764, but here we have 21671, so let's try that. Okay, so with an exploit like this, where it is a program written in something like C, we're going to copy the text, come to our attack box. We'll just name this something like do openf. Okay, and then we'll paste the code in, save. You don't have to use Nano, that's just my text editor of choice. And then we need to compile it. So the command to compile it is GNU C compiler, GCC, openf. So that's the input file. And then, sorry, I missed the O flag. Let's also open this back up. There you go. Okay, and then we name it. So I'm going to name it openf.c. I forget what all these flags are. Let me take a look at that for you, but first let me put this in here. LC. Oh, L crypto. All right, let's take a look and see what that was. GCC help. Okay. So the L crypto option is literally to link the program with the OpenSSL cryptographic library, which we need. It stands for libcrypto, library crypto, which we need because this is an OpenSSH vulnerability. So of course we need that library. That makes sense. And then the O flag was for, that was the correct syntax. Okay, we'll see. All right, so does say on that first line updated exploit that location. So I went to that location. Let's try this again. Give us some space. Clear out the file. All right, let's try without doing anything else. Ah, okay, voila. All right, so reading is fundamental, friends. So look for lines like that when you're using exploit DB. Yeah, that was apparently all we needed. We just needed to go to the updated code. Okay, cool. So now let's do the thing. Yep, we can look at help. Okay. Wow. Okay, lots of supported offsets. Woo. Have I seen any of these in the wild? Any of these versions, obviously. I've never exploited this before. No. No, not that low. But cool. So it's all here. So we need to find our version here. So the 0 times blah blah blah. And it was Red Hat, Linux. Let me see if I can do it without looking at the thing. Without looking at the other person's write up. So it was Red Hat. It was 2.8.7 on the SSL. I know these are all saying 8.4, but it was back ported to 8.7. Yeah, we're gonna have to look at the write up. Sorry, friends. I am trying to do this on my own without the write up, but I'm not that elite yet. Okay. Supported offset, blah 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 blah. Okay, so it was the 6B, so Red Hat 7.2, Apache 1.3.20 to 16.2. Six B. Yep, same thing. Okay, cool. So we will use that. Oh, well, that's not the right IP at all. No worries. 0x 06B, or was it just 6B? 6B. Pick back up. Okay. 443 should be. Back to this. View. Yeah. Okay. Oh. All right. So going the previous route, the Samba route, we got straight to root. This we are at the Apache level. We are not at the root level. Okay, so next. Oh, okay. Well, this says that we may have had to run it several times. I only needed to run it once, so that's pretty cool. Yes, this is Ryan from way back to the future. First and foremost, I totally missed the opportunity to say, I'm in. But also, I'm recording this in post-production to really lean into how and why this exploit works. So first, what is OpenSSL? OpenSSL is a crucial tool for securing online communications. Ironically, it is intended to provide a way for applications to encrypt data, ensuring that even if someone intercepts the communication, they won't be able to read it. This is known as an adversary in the middle attack or a man in the middle attack, depending on your study content. So this exploit is taking advantage of an SSL version 2 protocol handling issue. This OpenLuck exploit targets the vulnerability in how OpenSSL handles the SSL v2 protocol, or Secure Sockets Layer version 2. So SSL v2 is an older deprecated version of the Secure Sockets Layer protocol, which was used for securing online communications, but this has been found to have vulnerabilities. So the specific issue occurs during the negotiation of the SSL v2 protocol between a client and a server handshake. A malicious client can send a specially crafted packet of data, like we did, to the server, exploiting the server's weakness and handling that client's key value during the negotiation phase. So there's two main components to this exploit. There's a buffer overflow, which, if you are unaware of what that is, it's definitely important that you understand what a buffer overflow is. So imagine a bucket that can hold a certain amount of water. If you try to pour more water in the bucket than it can hold, then the excess water spills over the sides. So in this analogy, the bucket is the buffer and the water is the data. So if a program tries to store more data in a buffer than it's designed to hold, then the extra data can spill over into adjacent areas of the computer's memory. So this can cause the program to behave unexpectedly. So that's issue number one. Issue number two is the protocol handling issue, specifically with SSL v2. The issue is not just in overflowing the buffer, but also how the protocol negotiation is handled. So with that OpenLuck code, we were sending specially crafted data to the server during that SSL v2 negotiation phase. That's why I had to back out and go back in, exploiting the server's weakness and handling the client key value. So by exploiting a vulnerability like this, a threat actor may be able to execute arbitrary code as the vulnerable server process. So even though the privileges are limited to the process's permissions, this can still lead to potentially a complete takeover of the system, as you're about to see in the next part of the video. The key to protecting against exploits like this is keeping software up to date. When vulnerabilities are discovered, developers usually release patches to fix these weaknesses. Applying those patches to the affected asset promptly can prevent the exploit from working. Also, disabling or avoiding the use of outdated insecure protocols like SSL v2 is crucial for maintaining the security of online communications. Obviously, the entire demonstration is using assets and vulnerabilities that are very old and obsolete, but the same principle holds true to vulnerabilities even just discovered last week. You gotta patch it. All right, so now that we have our foothold, let's escalate our privileges to root level. Back to me. Oh, okay, so this is a cool GitHub. Okay, so this is kernel exploits on Linux. I'm actually gonna bookmark this. What do I want to put this under? Yeah, hacking. All right, cool. So we can search our kernel. which was 2.4.7. Oh, okay, so then we just pick one of these. Okay. And all right, well, let's do our own. Let's see what they used and let's try something different. Okay, they used pipe C 32-bit. Oh. Okay. How did you get in with root? Oh, okay. Did something else here. All right, let's look this up. Race kmod. Okay, yeah. User privilege exploit. Alright, so we need to get this onto it. Okay, so what I did was, not sure how that happened. So I've set up this HTTP server, and when I used this exploit to shell in, I used the command wget to the HTTP server / this file, but for some reason it changed it to hmod. So let's go in one more time instead of kmod. So let's move ptrace hmod.c to ptrace kmod.c. Okay. Okay. Now let's exit. Let's try it again. Oh, had an error. Shoot. Record length out of range. I mean, let's try it again. Maybe it just takes a few tries. All right, let's try 6A. No. So it's definitely 6B. As such file or directory. Okay, still Apache, but it did something different that time. It did say, I may need to reboot it. Wonder if it'll, let's try it one more time. Boo. All right, so we need to do it again. wget http .343 ptrace kmod.c. Okay, saved. Okay, that's better than what we got last time. Shut down. Reboot now. Reboot. All right, whatever. Let's just exit. All right, let's try it again. No. Oh. Okay, so we had to run it a few times. And it didn't like the wget the first time. I did try that a second time as well. It's doing something here. Is this a shell? Aha, we're in a shell. All right, a working directory, great. All right, so let's copy all that code. All right, so once we have that, we can get the flag. So we'll do the same thing. You do the this command, this head command. Ta-da. Flag received. Okay, cool. Well, that was certainly an adventure. Thanks for coming with me on that. Thanks for dealing with my issues and errors. But I definitely learned a lot of valuable lessons. But I hope you enjoyed. I sure did. It was awesome to learn a whole bunch of new stuff. I can't wait to get into the next one. But thanks for joining me on this adventure, friends. I'm going to go get another beer now. Kia ora. Alright, so before we close out, let's level set on what just happened with that privilege escalation. First, let's talk about what a Linux kernel is. The Linux kernel is the core part of the Linux operating system. It manages the system's hardware resources and provides services to applications running on the system. Think of the kernel as like the brain of the operating system. Windows has a kernel, Mac has a kernel. This is a normal part of an operating system. Now, part of what makes Linux so great and appealing to me is the kernel modules. So a kernel module is a piece of code that can be loaded into the kernel to add new functionality or modify existing behavior. So kernel modules are like plugins for the kernel. And like I said, this modularity is part of Linux's appeal to people like me. So what is ptrace. I think I said like ptrace or something in the recording, but as I've been looking into stuff, I think that the correct way to pronounce it is ptrace. I also really don't concern myself with the way things are supposed to be pronounced, so whatever. But the ptrace is a system call in Linux that allows a process to control and inspect the execution of another process. So this is commonly used for debugging purposes, such as when a developer wants to see what's happening inside a program. So what is the ptrace kmod exploit? The ptrace kmod exploit is a type of attack that targets a vulnerability in the way the Linux kernel handles ptrace requests. The exploit involves loading malicious kernel module that exploits its vulnerability to gain elevated privileges, which is what you saw us doing. All right, so here's a simplified overview of how that exploit works again. So the attacker loads the malicious kernel module. That was that wget request that we did. So we did that wget, and that kernel module had the malicious code in it that we pulled down from our HTTP server on the attack box. So then that module exploits the ptrace vulnerability. The malicious kernel module exploited it in the ptrace system call to gain control over the kernel. And step 3, profit, or elevated privileges. So the exploit allowed the attacker, which was us, to gain the elevated privileges such as root access, which gives complete control over the system. So the ptrace kmod exploit is a problem because it allows the attacker to gain control over the system without being detected. This can lead to a range of malicious activities, such as stealing sensitive data, which was kind of what that was emulating with going into the root emails. We could have installed malware or disrupting system operations. When you have root access, you can do whatever you want. So to prevent the ptrace kmod exploit, it is essential to keep the kernel up to date, ensure the Linux kernel is updated with the latest security patches, use secure kernel configurations, configure the kernel to disable unnecessary features and modules, monitor system activity, regularly monitor the system activity to detect and respond to potential security incidents. Use security tools and technologies. Use security tools and technologies such as SE Linux or AppArmor to restrict the execution of malicious code. That's it for Kioptrix, friends. So thanks for joining me on this journey. I've been using Parrot OS for about a month now, so my next video I'm going to break down the differences between Parrot and Kali, and I'm also probably going to be beautifying it a little bit, so hope to see you join me for that. Kia ora.